Many manufacturers now feed their engines with electricity, but given a company like JCB that specializes in creating engines for huge machinery, is this practical for all manufacturers? Simply put, electric engines are insufficient. This is due to the fact that electric engines are unable to produce the kind of power that is required by this massive, heavy machinery. If diesel engines are replaced with batteries and heavy lifting machinery, it will be a compromise of power for less dangerous pollution, and quite honestly, other automakers can afford to make that sacrifice, but not JCB. For some operations, including those involving agriculture and construction, powerful machinery is required. As a result, JCB realized that their issue needed a unique solution. They concluded that all they needed to do was create green engines. Beginning in 2020, JCB began working to develop hydrogen-powered engines with properties similar to those of diesel engines, but this time with an emphasis on environmental preservation. Even though JCB hasn't yet started mass-producing hydrogen engines, they have made important advancements in the last few years. Due to the fact that hydrogen engines are the wave of the future, the corporation is advocating this approach. Innovations in technology, such as the creation of electric vehicles, have shown that little equipment that doesn't require a lot of energy may be powered by electric engines. Big trucks that are powered by electricity have yet to be developed, but this is only because they demand more energy than batteries can provide. Examples of such vehicles are those built by JCB. Therefore, EVs are unable to supply this quantity of energy. Giant-sized batteries would be required for these machines, but carrying them would require more weight and space, which is not viable. What makes this clear to us? Before deciding on this course of action, JCB had already tried a number of fuel alternatives. A fuel cell built by Nissan was installed by JCB in a prototype 20-ton X-Series excavator in 2019. The company looked into a number of options and came to the conclusion that battery cells were too pricey and specialized for heavy machines. Using these fuel cells, according to JCB's analysis, would make these machines about 3 times as expensive as equivalent traditional diesel machines already are. Due to running costs, which were not excluded and were predicted to climb dramatically, purchasers would not be able to afford to purchase this battery-powered heavy equipment. That is, if they ever managed to find commercial success. With the goal of achieving zero net emissions in mind, JCB began developing its hydrogen engines. According to Chief Innovation and Growth Officer Tim Burnhope, an automobile and a machine are extremely different from one another. JCB deals with machines. Tim thinks that JCB needs to find answers for their equipment and their target market, as well as the fact that while electricity may be the most popular fossil fuel substitute for diesel, it's not the only one. Tim makes a good point, and we have to agree. The initial idea for JCB was to convert diesel engines into hydrogen engines. During the process, they realized that conversion would not be successful. Later, they abandoned the idea of modifying and started over to produce 100 internal combustion engines driven by hydrogen. The aim of JCB was to create hydrogen engines that were equally effective as diesel engines and produced no greenhouse gases. Attaining this objective would not be easy. However, after 2 years and more than 50 prototypes, the company has finally settled on a patent they are comfortable with. The exterior of the JCB hydrogen combustion engine bears little resemblance to that of a diesel engine. Drivers won't be able to tell the difference when driving, claims Ryan Ballard, head of engine development at JCB. They could only tell there was a difference in how noisy the engine was, which is good. By the way, the new hydrogen engine has the same torque as a diesel engine, so it can generate enough power to handle demanding conditions. It does, however, have a somewhat higher peak efficiency when compared to diesel engines. We predict that JCB engineers all over the world won't have too many difficulties when working on hydrogen engines, given that they are comparably similar to diesel engines. The bottom end and capacity of JCB's hydrogen engines are actually the same as those of diesel engines. What is the process for the JCB hydrogen engine? Since hydrogen has a substantially lower density than diesel and can be injected at lower temperatures and pressures than are feasible in diesel engines, the conventional diesel injectors in the hydrogen engine are swapped out for hydrogen injectors. A spark plug is then used to inject hydrogen. In contrast to diesel engines, this engine requires a spark plug to start the gasoline, as it does not ignite spontaneously. If you think this video has been interesting so far, make sure you subscribe to Carbate, like the video, and let's continue. The balance between the hydrogen and the air inside the engine must be exact for combustion to occur. Tim asserts that it must take roughly 28 milliseconds to create this homogeneous mixture. This is accomplished by quickly adding extra air to the engine using a high-efficiency turbocharger with low inertia. Burning air at a specific temperature has the ability to make nitrous oxide. On the other hand, no pollutions are created because the combustion in the hydrogen engine takes place at low temperatures and pressures. The hydrogen engine is also significantly cleaner than diesel ones. Due to its carbon-free burning, the engine doesn't emit any carbon dioxide. A byproduct of the combustion process inside the engine is steam, which is released through the exhaust. Ryan Ballard refers to this steam as dry steam, and the engine uses a special lubricant to manage it. This oil, which does not emulsify when in contact with water, prevents water vapor from entering the engine. The hydrogen engine on a JCB is also very simple to replenish. The majority of the huge on-site bunkers that have a lot of storage capacity are used to power heavy equipment. A Bowser is essentially a tank used to transport fuel to large machinery. The same technique is also used to power hydrogen-fueled internal combustion engines, and JCB has already developed a hydrogen storage tank with a 100-kilogram hydrogen capacity. It requires a working pressure of 500 bars and a machine pressure of 350 bars to operate. This approach does not require a pump because refueling is accomplished using a straightforward decantation procedure. As a result, a complete tank of hydrogen fuel can be comfortably filled in a short period of time. Obtaining hydrogen fuel, which goes beyond refueling, poses a bigger problem. This must be the most difficult challenge in adapting diesel engines to run on hydrogen fuel. We have a wide range of fuel options, but where do we get the hydrogen fuel required to power these new engines? The most common element on Earth is hydrogen. However, even though it's common, it is rarely discovered in its pure state, and only pure hydrogen can be used as fuel. But given that JCB has developed an engine that runs on nothing but pure hydrogen fuel, it's safe to assume that the business has its sights set firmly on the future. The next obstacle will be the accessibility of green hydrogen. It's clear that progress is being made, even though we are still a long way from a future with no carbon emissions. On a more positive note, a number of countries have started taking steps toward the production of hydrogen fuel. But why even bother going down the hydrogen fuel route? Toyota is an ardent supporter of hydrogen-powered vehicles in the future. JCB is not the first to imagine a world in which hydrogen is dominant. We believe that this is solely due to the numerous benefits that hydrogen engines offer. In spite of the limited availability of hydrogen fuel, we are confident that hydrogen engines will outperform diesel engines. Thanks to hydrogen fuel, we now have a far cleaner substitute for diesel and gasoline. The net emissions of carbon dioxide from hydrogen combustion engines are zero. The chemical process that takes place inside the engine is carbon-free, and dry steam is produced at the end product once more. The driver doesn't need to make any adjustments for combustion engines driven by hydrogen, at least not now. Similar to diesel-powered vehicles and, intriguingly, hydrogen-powered vehicles, the cars perform exactly the same. JCB claims that they are somewhat more efficient than electric batteries and that when power and torque are taken into consideration, they trace a curve resembling that of diesel engines. Engines powered by hydrogen are more cost-effective for heavy-duty machinery. The net weight of the machine is not much increased by them either. The weight and space requirements for electric batteries that can supply enough energy to power the massive machinery can occasionally be too high. Our confidence has substantially increased thanks to JCB's new engines, even though we had some concerns about how they would function a few years ago. According to the engineers of the company, hydrogen-powered cars are the future. Hey, thanks for watching. Toyota has been adamant that they do not feel EVs are the solution, and they may be right. The company has now developed a new internal combustion engine that runs on hydrogen, and the company's CEO says it will destroy the entire EV industry. We can only hope. If you want to know more about how this engine will kill the entire EV industry, then click on the left. And if you don't want to miss any videos, then please click that subscribe button.